Welcome to Hope Academy. My name is Mr. O, and today I will be covering the concept of logarithms. One of my students wanted me to go more in depth around the rules and to have sort of like a reference for her to be able to study, and so I shall do that for today. So when I am talking about logarithms, there are a lot of different rules that exist based on logarithms. But there are a primary several rules that do exist for logarithms, along with some side equations that you should know about. So I shall get started. So there are a few equations, standard equations that do usually come up quite commonly. I do want to mention. So these three types, primary types, are called the power rule. And I'm going to bring it down a little bit. So this is based on logarithms. To title this, logarithms. So power rule is one rule. There is the product rule. And there is the quotient rule. And each of these rules play a big part into many of these different logarithm equations that we work through. And so be aware that whenever someone mentions these type of rules, that you know which rule to apply. And be also aware that you can apply more than one at the same time. And so I shall go ahead and explain each one. So for logarithm, for specifically the power rule works like this, where if it says log a x to the n power will equal to n log a to the x. So it looks like this. And so the reason why it works like this is that a rule in logarithms exists where basically I could take this power that I have right here and bring it down to become the coefficient, and thus why it looks like this. And so that's the first rule. The second rule that exists looks like this. So it will be log a of your x, y equals to your log a of your x plus your log a of your y. And so for this rule in particular, whenever you see two numbers that are multiplying, aka right here x is x times y right here, you can actually separate it out into two separate logarithms. Do note that the base value will always consistently be the same value. So for this case it is a, and thus you could create two equations like this. And for the last rule, the quotient rule, it will look something like this, where log a of your x over y equals to log a of your x minus log a of your y. And so for the last rule right here, what happens is that just like as much as when multiplying it becomes the plus format, when I'm doing division right here, it will actually become subtraction. And duly note once again, the base values will always consistently be the same. So whenever we are working with these three specific rules, the base value will not change. But be aware that based on certain questions, if base values are different, such as for example, if it says log 2 of 3 plus log 3 of 4, for example, you cannot combine those because the base values are different. You have to note that these base values have to always be consistently the same in order to be able to apply these logarithmic rules. And so just be aware of this when you're working through this. There are also a few other rules I do want to mention that you must make sure to know before we continue. And these are the few other rules. And there's no name for these specific rules. They're just sort of equations that you need to know. So you need to know that whenever I see log a of 1 equals to 0, this is always the case. So this is one side rule. So why this is the case, it's just how the rule works. Another way you could think of this is that another rule that works is that I could actually shift this a right here up to here, and it could actually become 1 equals to a to the 0 power. And you know that if I put 0 power to anything, it could be 100 to the 0 power, it could be x to the 0 power, it could be abc to the 0 power, right? What happens is that if I have something to the 0 power, it will always be equal to 1. And that's an exponential rule that you must remember. And thus why this first equation right here will always be a standard rule that exists. The second side rule that does exist is the fact that if I say log a of a will always equal to 1. So if it says log x of x, it will equal to 1. If it's log 3 of 3, it will equal to 1. If it's log 2 billion to 2 billion, it will always equal to 1. And that is a rule that you must also remember and follow by. And the last little rule as you notice, it's sort of similar to the power rule, but the last little rule you do need to know is if I have log a to the r will always equal to r. And part of the reason why is that when we are dealing with logarithmic rules, if I have a power right here, like the power rule, I could bring the r down here. Thus, it'll be r log a, and we mentioned a will equal to 1. Thus, this value right here will become 1. So in the end, that will just be equal to r, and thus why this rule works. And so these are the particular rules that I am going to be focusing on today and will be using constantly throughout my solving. And so make sure that to have this either copied down or make sure to try to memorize these equations. I especially recommend memorizing these because it becomes a lot easier once you have these memorized and you practice applying them to the problems. And so on the next page that I'm going to flip to, I actually have a set of problems just ready for us to practice through, just using these rules and understanding how these rules apply based on different circumstances. So for the first question right here, so what I have log 3 of 9, and I'm asking you to solve this type of question. And I'm going to go ahead and show the work here. So I'm going to put dotted line so you don't get confused in these questions. And so the point is that when we are doing these type of questions, log 3 of 9, technically log 3 of 9 will equal to x because we don't know what the value of x is. We are looking for that answer x. That's what we are solving for. And as I mentioned before, one of the rules mentions that I could take the 3 and shift it over to where this x is. So in the end, it will be 9 equals to 3 to the x power. And a lot of times when we're looking at this type of question, we have to think, well, what 3 times to what power will equal to 9? And if we think about it, 3 times 3 equals to 9. Thus, because 3 times 3 equals to 9, we can remember that x will equal to 2 for this question. And this is my answer for the first question. So we're starting off with a little bit of a simple question. It didn't apply any of the product rule, power rule, or quotient rule per se, but it's a good way to just start warming up for it. Okay, and so we shall continue to the second question. So the second question shows this. It's log 2 of your x over y cubed power. And there are actually 2 ways to solve this question out. So I'm going to split this into 2 ways. This is number 1 way. The first way you could solve this is by distributing the 3 to each part right here. So for example, because this is an exponential rule, I could actually change this to x cubed over y cubed like this. So from here, I have 3 distributed to both parts, and this is what I can get. Afterwards, when I get to this part right here, what I can do is that I could use the quotient rule. And the quotient rule, if you want me to review it, right here I'm going to write the equation. Log a of your x over y equals to log a of your x minus log a of your y. This is the equation. And so for this equation, I could actually make that happen where it's going to be log 2 of your x cubed minus log 2 of your y cubed. But I am not done. The main reason why is that remember that whenever you see either a multiplication, a division, or a power, we can actually simplify the equation even more. And so for this question right here, I could actually simplify out the y cubed and x cubed because of these powers and bring them down. That is what I am able to do, bring them down. And so this will be log 2 of your x minus 3 log 2 of your y because of the power rule. The power rule allows me to make this happen, and this will be my final answer for the question. But let's say that you forgot how to do this method or you prefer another method instead. This is the other way you can go about doing this. So for the second method, rather than bring these into the parentheses right here, I could actually apply the power rule automatically. And so that means that I could bring the 3 to the front right off. So I'm going to write that straight out. So when I do that, this is what's going to happen. It's going to say 3 log second base of your x over y. And so this setup works, but the problem is that a lot of people might make a little mistake along the way, so make sure to be careful. What happens is that what you can do afterwards is that I could use the quotient rule once again. Just be aware that when I use the quotient rule, this whole thing will actually be a parentheses like this. Because this rule of quotient rule only applies to this specific portion, not including the 3. Afterwards, I could distribute the 3 and make it like this. And it is exactly the same answer as this. Both ways work perfectly. It's dependent on what you prefer. And so that concludes how I was able to solve for the second question. And to continue on to the third question, so going down to the third question. So for this question right here, the log 5 of x, y, z, the thing I identify is that there's only multiplication going on. And so because there's multiplication, I need to remember the product rule. And I'm going to write the product rule down here, where it's xy equals to log a of x plus log a of y. And so this is the primary rule that will help me solve this out. Be aware that each time I'm breaking down a component in here, each of them are attached by a log as a reminder. And so for this question, because I know there's x, y, and z being multiplied, each of these could be broken apart and I could solve it out. So it'll be log 5 of x plus log 5 of y plus log 5 of z. Be aware, I changed the base value to 5 because a is going to be 5 in this question, x, y, and now there's an extra addition of z, which is perfectly fine. I just need to do an extra log to include it, and that concludes how I could solve for number 3. And to the very last question for number 4. So when I am looking at number 4, there's a lot of things going on. First things first, I see is a fourth root going on. I see multiplication, I see division, I see a power rule going in. So all three rules are going to be applied. The product rule, the quotient rule, and the power rule. And so when I'm doing this question, I need to break this down step by step and make sure I'm good to order to solve this out properly. And so for number 4, this is how I'm going to go about doing so. So let's see. So I'm going to change this root 4 to the power format. It's going to be the exact same question, but right now I am going to actually encapsulate this x squared y over z to the 1/4. Be aware that whatever, if there's only a square root here, it will be half. If there's a 3 right here, there'll be 3. There's a 4 for this question, thus that's why it's going to be 1/4. And so depending on the question, very similar to number 2, where I could take 2 routes, I'm just going to choose one of the routes to make it easier for myself and then go ahead and just solve it out. So personally for me, I actually like moving the 1/4 out automatically onto log. The main reason why is because then I could just deal with it later. Just need to remember that if I'm going to take this route, the second route right here, I need to keep the 1/4 out and make sure to distribute to every part in the very end. So that's what I need to make sure to do. So for this question, I'm going to state that this is equal to 1/4 log 3 of x squared y over z. Okay, now I need to deal with the parentheses in the logarithm. So I see x squared y, which is going to be a power rule with a product rule involved with divided by z, which means that there is a quotient rule involved. So I'm going to break this down. So I'm going to take care of this multiplication and note that it's going to be 1/4, in parentheses this whole thing, log 3 of, now it's going to be x squared plus log 3 of y. The reason why is because x squared and y are being multiplied with each other. Thus, based on the product rule, I could make it add to each other. Now I need to take care of this divided by. So it will be subtracted by log 3 of z, because the quotient rule allows me to subtract and create that sort of format for this question. And so after I get to this format, I'm not done, partially because I didn't distribute this, but also because I have a power right here. And we know a rule that helps me take care of that. So I'm going to continue on and solve that out. So 1/4. So I'm going to bring the 2 down here. So 2 log of 3 of my x plus log 3 of my y minus log 3 of my z. And thus, because this is not completely done, I need to distribute the 1/4. I need to make sure to do so. And I'm going to continue that on a separate piece of paper because I'm running out of space. But what happens right here is that it will distribute out to become 1/4 times 2, which is 2/4, log 3 of x plus 1/4 is going to go here. So 1/4 log 3 of y minus 1/4 log 3 of z. But I could simplify this fraction, and I'm just being very thorough so you know every possible step that is needed in order to solve this out. But I simplify 2/4 to half because it's equivalent to each other. And this is my final answer for this question. And so for number 4, this is my final computation for this question. But I realized that there is also not, be aware that just as much, whoops, let me leave that alone, just as much as it is as much as I could apply the quotient rule and make it happen like this, be also aware that we can actually go backwards for these questions. And so for the next question for number 5, I'm actually going to create it right here and think of like a question that will help us understand what we need to do. So I'm going to put something like this. So log 3 of x, minus 3 log 3 of y plus 4 log 3 of z. Okay, so for this type of question for number 5, and I'm going to box it so you know this is a question. For this question, I'm going to be asking you, how do we go backwards from here? How do I go about solving this? And I'm going to move this out of the way now. But how do we go about solving this question so that we could solve it out? And this is how you're going to go about doing so. So because we see subtraction, we know there's a quotient rule. Because we see the plus, we know there's, so I'm going to write that down. Quotient rule is going to apply here. Product rule, product rule is going to apply here. And I know power rule is going to apply because of these coefficients right here. So let's take care of it first by using power rules here. So these are going to be power rule, power, and power. And do we know this is a 3? I accidentally circled the L in log, but it's only just the 3. And so when I'm doing the power rule, for example, I could actually change these by moving these back up. So log 3 of your x squared, and then minus log 3 of your y cubed. And then we're going to continue on and make it plus log 3 of your z to the 4th like this. Okay, and afterwards, now I can apply the quotient rule and product rules. Be aware that doesn't matter if the negative sits right here. It's not going to distribute to other parts or affect other computations. Also be aware that because a commutative property, which is an old terminology we used a while back in Algebra 1, commutative property lets you switch these around. And so be aware that this is going to be x squared times z4. So log 3 of, I see these are multiplying together, so it'll be x squared z4, and this is going to be my divided by y cubed, and that concludes, this is my answer for this question. And that concludes my explanation for today. So make sure to review over this concept, make sure to see if there's anything else you might have questions on, and feel free to let me know if you have any questions on this concept or want me to elaborate on anything else. Thank you so much for watching this video. Please do like our Facebook page or subscribe to our YouTube channel so that we could continue to make content like this. I hope you have a wonderful day.